Welcome back, everyone. Today we're going to focus on 3D objects and nets, so being able to describe a 3D shape and its properties. This is something that I've been asked to focus on by my students, so I thought it would make a good video. But before we start looking at 3D objects, the first thing is to establish what the different dimensions are. So we could have the first dimension, which is a length, okay? So the first dimension is when we are describing lengths or distances. The second dimension is as follows. You've got an area, so on a flat plane. So we've got two dimensions here, both width and length. But third dimension is an example like this, where we have width, length, and depth. So we've got three dimensions there, and questions like this often involve volume or capacity. But today we're just establishing the different names for our 3D objects, our shapes with three dimensions, and as well as looking at nets. We've got some important terminology we need to know here. So a face is a side of the shape that can be flat or curved. An edge is where two faces of the shape meet, and a vertex is where two edges meet. I've got a diagram to help you. So this has a rectangle face here. So this has 6 faces and they're all rectangular shaped. This is an example of an edge, because you can see here, this is where my two faces are meeting. So that's an edge. And a vertex is where my two edges meet. So hopefully this visual representation helps you to establish what the difference between these three different words are and their terminology. Let's do a couple together. So I've got some different objects here and their names, but I just want you to have a think of how many faces, edges, and vertices they have. So pause the video for a moment and then we'll talk through the answers together. Okay, so first we have a cube. You could also call it a cuboid. A cube is just more specific because all of the faces are the same. And there are 6 of them. We've got 6 faces here. 6 squares make up this shape. There's 12 edges. So 1, 2, 3, 4, 5, 6, so on and so forth until you get to 12. And there are 8 vertices. That's probably a bit quicker. 1, 2, 3, 4 here, and another 4 in the back square to give you 8 in total. A cuboid is actually exactly the same, because we can think of a square as a more specific type of rectangle. So you can see lots of rectangles here, and a square is just a rectangle where the lengths are the same. So in terms of faces, edges, and vertices, that is exactly the same as this one. We can also call this a square-based prism. So prism is an important term. A prism is when you can fit the same shape all the way through. So this rectangle, if you try to push it from the front to back, it would fit all the way through. Same with this one here, this triangle, if you try to push it from front to back, it would fit all the way through. Same with this cylinder. However, this sphere isn't the case. So that's an important definition of a prism. Most people don't know what the difference is. So if you had something like a pyramid, you couldn't fit the shape all the way through it, which is why it's not referred to as a prism. But this triangular prism, let's focus on the faces here. I can see a triangle at the front, a triangle at the back, and then I've got a rectangle here, a rectangle on the other side, and one rectangle on the bottom. So that made 5 faces. They are connected with 9 edges as well as 6 vertices. Okay, so if you got that right, really well done. The next two often confuse people, so it is not as common. But remember, a face can be wrapped round. So a cylinder actually has 3 faces. One circle here, one circle at the back, and then there's a rectangle wrapped around it. It's got 2 edges because if you unfolded it to see the rectangle, a rectangle clearly has 2 edges, but there's no vertices. And then the sphere is just one face. It's like one big solid rectangle wrapped all the way around. But these two aren't common in LANTITE at all. You need to be able to establish what they are called, but not necessarily say how many faces and edges there are. We also need to be familiar with nets. So a net is like if you take a cardboard box and unfold it. So imagine you are packing, and this is your cardboard box. If you unfolded it, it would look like the following. So you would have a base, the bit on the bottom, you would have the front and the back, hence it says front and back, got two sides, left and right, and we would have a top as well. But try and imagine what your shape would look like if you unfolded it as if it was made out of cardboard, and that will help you establish what the net is. In the next slide, we're going to try and match some nets together, so let's have a look. So let's start matching these 3D shapes to the nets. First, we have a triangular prism, because if I was to push that triangle, I would be able to push it all the way through with no problem. Then we have a cylinder, also known as a circular prism, because again, I could push that circle all the way through. A rectangular prism, because I could push the rectangle all the way through, also known as a cuboid. And a square-based pyramid. Notice how I didn't refer to that one as a prism, because I could not take this square and push it from bottom to top. It wouldn't work. Okay, so this one is not a prism. So let's start matching these up. And when you do this, I encourage you to look at the faces. So my triangular prism, I've got 2 triangles and 3 rectangles. So I'm looking for a net which also has 2 triangles and 3 rectangles. So based on that, it must match to this one here. Got 1 triangle, 2 triangle, and then 3 rectangles around it. Next, we've got my cylinder, which has got a circle at the front and a circle at the back, and then a rectangle wrapped around it. But this is the only net with circles on it, so that is probably a big clue that that has to be the one that matches. I've now got my rectangular prism, my cuboid, which is made up of 6 rectangles, or these look like squares on the side, but a square is just a type of rectangle where all the side lengths are the same. But this must match up to this one here, because I've got 6 faces, all rectangular shaped, and this has 6 faces, all rectangular shaped. And then last but not least, I have the joys of my pyramid. So my pyramid must match up to this one straight down, but you can see the square on the bottom, and there's a square here, and then 4 triangular faces around it, and hence the 1, 2, 3, 4 triangular faces. So thinking of how your 3D shape looks as a net is a good way to establish how many faces that shape must have. This is taken from NatPlan, and NatPlan is a good resource to start building you up to a LANTITE level. Now remember, a prism, we need to be able to fit the same shape all the way through. This one is a square-based pyramid. I've got 1 square and 4 triangles. So that one won't work because I won't be able to get the square from top to bottom. So that is not a prism. Here, this is another pyramid, okay, but it's not a square-based pyramid. So if you picture a pyramid with a triangle on the bottom, you wouldn't actually be able to fit that bottom triangle from top to bottom, so that is not a prism either. You might recognize this one as a triangular prism. So if you recognize that as a triangular prism, we've established that you could fit the triangle all the way through from like front to back. If you push the triangle, it would fit all the way through. And this one is a cube. And that is definitely a prism because every square is the same size. So you could definitely fit the square all the way through if you were to push the front face. Here it says we've got a square pyramid. Which diagram is the net of a square pyramid? So I know we've gone through this quite a few times, but if you were to figure out what the answer was, I would encourage you to look at the different faces. So I can see a square on the bottom and I can see 4 triangles. So if I look here, I've got 1, 2, 3 squares, definitely not that one. This has a square on the bottom and 1, 2, 3, 4 triangles. So there we go, that's my answer. But just to check, 4 triangles. And then here we've got 2 triangles and 3 squares. So they definitely don't work as well. So just to emphasize again, when you're looking at the net, it is a good way to establish how many faces there are and vice versa. So that will probably help you convert between the 3D model and the net as if you've unfolded it like a cardboard box. Check out the video above where I cover more concepts and material that is in the LANTITE assessment. You can also check the description below where I've got an entire course dedicated to LANTITE, which has loads of videos such as this one, but most importantly gives you a bunch of material and practice questions which you can use to help prepare you for your assessment day.